Hello again, everybody. Mr. Kunkel here, working on kind of the last little bit of exponents for now. Today we're going to look at simplifying exponential expressions. There was a practice for this online. It seemed like we had some trouble, so I just pulled some examples and I'm just going to start working through some examples. I'll write down a problem and I'll kind of pause, and I'd encourage you to pause the video and try to work it yourself and see what you get, but then I'll write it down, pause for a second, and then go ahead and work the problem. And I'm going to go through quite a few of them just to give y'all examples of how it works. I have some written down here, so let's go ahead and dive into it. Let's say we have 1 over, let's say 2x to the negative 3. And then here's where you would pause and go give it a shot. But if you pause, great. We're going to go ahead and work this one. So we have 1 over, and this 2x is in parentheses, so that means we need to distribute this negative 3. Remember, we can think of this as 2 to the first and x to the first. So these are both powers being raised to a power. So this is going to become 2 to the negative 3 and x to the negative 3. Now remember what we said about negative exponents. Both of these, we need to make them positive exponents, so they both need to go to the top. So this is going to become 2 to the third, x to the third, over 1, since these both moved up. Last, we can simplify it. 2 to the third is 8. X to the third doesn't simplify, and we'll get rid of that 1 on bottom, so we're left at 8x to the third. Let's look at another one. We've got 3y to the negative 4. Go ahead and try that on your own. Alright, so let's look at this. These are both in parentheses, so everything in the parentheses is being raised to the negative 4 power. So just like we did earlier, let's pretend both of these are being raised to the first. We have a power being raised to a power, so this is going to be 3 to the negative 4. And then y to the negative 4. Once we get here, these are both negative. We need to make them positive. So we have 1 over 3 to the positive 4, y to the positive 4. Last thing, we can simplify to that 3 to the 4th. If we put that in our calculator, we get 1 over 81 y to the 4th. So here we had the parentheses. So that meant both of these, the 3 and the y, were being raised to the negative 4. So remember, just like we did here, that negative 3 has to distribute to the 2 and the x. Here, that negative 4 has to distribute to our 3 and our y. Once it distributes, these are both negative. To make them positive, they have to flip. And then we simplify from there. Remember, we're just trying to simplify these problems as much as possible. So we have 3x to the 0, y to the 4th. Go ahead and try that, and then I'll work it. Okay, so what can we do here? We don't have anything in parentheses, so all we need to do is see if we can simplify. The 3 isn't being raised to an exponent aside from, you could technically say 1, so the 3 stays. X to the 0, remember our laws of exponents. Anything raised to the 0 power becomes 1. So that becomes 1. Y to the 4th cannot simplify, so that's y to the 4th. So that 1 can go away. We can just call this 3y to the 4th. And that is our answer. Let's look at one more kind of basic one. 9x to the negative 3. Give you just a second to try that on your own. Pause the video if you need to. Alright, so unlike the ones up here, this isn't in a parenthesis. So this negative 3 is just connected to our x. Our 9, we could say, is technically being raised to the positive 1 power, so we know that 9 is good where it is. This negative 3, we need to make it positive, so it needs to go down. It needs to go into the bottom of our fraction. So we can call this 9 over x to the third. When that -3 goes to the bottom, it becomes positive. We really can't simplify anymore from there. So that's all we need to do there. Okay, let's see, what else we got? Let's go ahead and jump into a little bit more challenging. We have 16 x to the 4th, y to the 6th, divided by, let's put a parentheses, -2 x to the 3rd, y, and let's raise all that to the 3rd power. This one's a little bit more challenging, but I encourage you to try it on your own. So if you'd like to, go ahead and pause the video here and try to work this as much as you can, and then I'm going to work it and see how you did. Okay, so let's start. We need to figure out what we can simplify first. Remember, order of operations, we need to deal with these parentheses before we deal with anything else. Everything inside these parentheses is being raised to the 3rd power. So let's go ahead and write in those ones. So remember that -2 is technically being raised to the 1st power, and that y is technically being raised to the 1st power. So we have 16 x to the 4th, y to the 6th, over, we have -2, and 1 times 3 would be 3. So -2 to the 3rd, x to the 3rd raised to the 3rd power. Remember, power rule says we multiply those, so 3 times 3 would be 9. And then y to the 1st power raised to the 3rd, 1 times 3 would be 3. And then that's where we're at here. Let's go ahead and work this -2 to the 3rd to get that simplified. We're going to be left with 16x to the 4th, y to the 6th, over -2 to the 3rd. Remember, we said if we have a negative base, we raise it to an odd power, it's going to remain negative. So -2 times -2 is +4. +4 times -2 would give us -8. X to the 9th, y to the 3rd. Okay, so remember our quotient rule. Quotient rule said that we subtract our powers whenever they're being divided. So let's simplify what we can. We're going to go ahead and simplify this. We have 16 divided by -8. 16 divided by -8 we know is -2. X to the 4th divided by x to the 9th. 4 minus 9 would be x to the -5. Y to the 6th divided by y to the 3rd. Y to the 6 minus 3 is y to the 3rd. Now remember, this 16 divided by 8, we can just divide those since those are constants to get -2. To get this x to the -5th, we did 4 minus 9 because they're being divided according to our quotient rule. And then y to the 3rd was 6 minus 3, which gave us 3. Remember our negative exponent rule? We don't want to have a negative exponent. We want to leave all of our exponents positive. So this is going to simplify to -2 y to the 3rd over x to the 5th. That's as far as we can take that. So that's where we will leave our answer. So a lot of steps in there, but really whenever you start breaking it down, not as complicated as it seems. It should be able to simplify fairly easily. Let's work just a couple more problems. Let's see. Let's look at x to the -3rd over -5, all raised to the -2 power. So we have x to the 3rd over x to the -3rd over -5 to the -2 power. Go ahead and pause, work that on your own if you can. All right. And now, remember our first step, we're going to distribute that -2, get rid of these parentheses. Remember, If we have a power and we raise it to a power, we're going to multiply. So let's remember this negative 5 doesn't have a power right now, so we're going to imagine it's being raised to the first power. Okay, so we have x to the negative 3 raised to the negative 2. Multiply those. Negative 3 times negative 2 gets us x to the 6. Over negative 5 to the 1. 1 times negative 2, since this is 1 being raised to the negative 2 power. That's negative 5 to the negative 2 power. Let's get rid of that negative by moving it up. So we get negative 5 squared x to the 6 over 1, because nothing's left in our denominator. Negative 5 squared, negative 5 times negative 5 is 25, so we should be left with 25 x to the 6. And that's all there is to it. I'm going to keep working problems, really trying to get some examples out there so you can kind of see the different ways we use this. Let's look at x to the 8th, y to the negative 14 over x to the negative 2, y to the 12th. Go ahead and pause, do what you can. All right, so we have negative exponents. Remember, we want to make those positive. So we want to take this negative 2, we want to move it up, we want to take this negative 14, and we want to move it down. So that's going to leave us with x to the 8th times x squared over this y to the negative 14 goes down, so y to the 14, y to the 12. So that x to the negative 2 went to our numerator. This y to the negative 14 went to our denominator because these were both negative. Since these are positive, they just stayed where they were. So now we got x to the 8th times x to the 2. Remember, these are similar bases being multiplied, so that means we're going to add these exponents. So that's x to the 8 plus 2, which is x to the 10, over y to the 14th times y 12. These are the same bases, different exponents being multiplied, so we're going to add those exponents. 14 plus 12 should give us 26. We can't simplify anymore, so we just leave it right there. Let's see, I have two more. Two more should kind of cover everything that we need. X squared, y to the 4th, over x, y squared. And let's go ahead and raise all of that to the 7th power. Okay, go ahead, pause, work it on your own, see what you can do. Okay, so let's think about this. What do we always say? I want to get rid of this parentheses. So if we're going to get rid of this parentheses, we need to distribute this 7. All of these are exponents being raised to a power. Remember, this x doesn't have 1, but technically it's being raised to the first, so we're going to write that 1 in to help us remember. So here we have x squared raised to the 7th power. Remember, if we have a power raised to a power, we're going to multiply. So that's going to be x to the 2 times 7, which is 14. Y to the 4 times 7, which is 28. Over x to the 1 times 7, which is 7. Y to the 2 times 7, which is y to the 14th. So we've distributed. All of our exponents are already positive. So now we just need to simplify. So we have x to the 14th divided by x to the 7th. These are the same base. So if they're the same base, remember, subtract our exponents. So that's 14 minus 7. So that's going to be x to the 14 minus 7 is x to the 7th. Y to the 28th divided by y to the 14th. Those are the same base being divided. So subtract your exponents. Y to the 28th. That's y to the 28 minus 14, which is y to the 14. Those both ended positive, so that's really as far as we can go. So that is our answer. Okay, last problem, and then we'll call it there. Negative 3 x to the negative 3 y to the 4th to all raised to the negative 3 power. Go ahead and pause it, work what you can. All right, so remember, first thing, again here, let's get rid of these parentheses. So if we're trying to get rid of parentheses, we're going to distribute this negative 3. So let's take this negative 3 and remind ourselves it's being raised to the first power. And these are all powers raised to a power, so what we're going to do, we're going to multiply these exponents. So this is going to be negative 3 to the 1 times negative 3. So negative 3 to the negative 3rd power times x to the negative 3 times negative 3. Negative 3 times negative 3 should give us to the 9th power. Remember, negative times negative gives us a positive. And last we have y to the 4th power raised to the negative 3 power. So that's 4 times negative 3 gives us y to the negative 12th power. Okay, so remember these were powers being raised to a power. So remember, power rule says if it's a power raised to a power, you multiply those exponents. So here, let's get rid of our negative exponents. Remember, if it's negative, it needs to go down. If it's positive, it's going to stay where it is. So what's left in our numerator? X to the 9th. And what's in our denominator? Negative 3 to the 3rd. Since we moved it to the bottom, it becomes positive. And then y to the 12th. We move it to the bottom, it becomes positive. Last thing we can do is negative 3 to the 3rd. Remember, if we have a negative base raised to an odd power, it's going to stay negative. So that's going to be x to the 9th over negative 3 to the 3rd should give you negative 27, y to the 12th. Oops. And just to clean that up, I'm going to bring that negative out in front. Just because I like to write it a little clearer like that. And that should be our answer. So this is just some practice problems that adds all of our laws of exponents together into practice. There is more you can do from here, but this is just kind of a baseline entry level, really starting to apply multiple rules at one time. But yeah, hope everything went well. Hope you tried to work the problems, and hope this helped you out with your exponents.